Hello. I'm going to do a quick video about perfect squares and how they are with quadratics. Kind of a background information for you, but that's okay. If you get it, cool. Perfect squares. They're very helpful if you have those memorized. If you ever did those like multiplication grids, and if you haven't and would like a copy and have no idea what I'm talking about, let me know and I'll let you know. All right. So what a perfect square is a number times itself. And I have here the first 20. I'm going to go through them very quickly. You can slow down the video if you would like, or speed it up, as well as repeat it if you need anything. Okay, so a number times itself. So for example, what this first one is it's saying, what is 1 times 1? I'm going to write this with different colors. So I'm going to say 1 times 1, which is 1. Okay, so what the base is our bottom number, right? Our base here is 1, and it's always brought to an exponent, right? In this case, all of our exponents are 2 because we're talking about a square. And if you take a second, fast forward if you want to, if you take a second to think about square and why we call it square, well, here's a square. If this square was 1 inch by 1 inch, then that means the area of this square is 1 inch squared, right? Because it's the two dimensions are multiplying by each other. So same thing here. If this was instead a 2 by 2, 2 times 2 is 2 times 2 is 4. So this would be a 4-inch square. Okay, so 4 inches squared, which is a little different. I know it's just language, but I'll put a pin in that for a minute. This is 3 times 3, which is 9, and I hope that you're seeing a pattern. 4 times 4. So it's always the base multiplying by itself the number of times for the exponent. So this is 4 to the second power, 16, 5, and I have 2 of them. 5 times 5 is going to be 25, and that goes throughout all of them, but I'm just going to move this for a quick second. Fill these all in. If you have questions, please ask me. 6 squared is going to be 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 100. And I would be remiss if I didn't remind us that, yes, this is in fact a quadratic, right? Because my first difference, if I do it in green, my first difference is 3, 5, 7, 9, 11, 13, 15, 17, 19, right? My second difference, 2. I'm going to erase this because it's not in there, but this was what we were doing before we left, right? So this is a quadratic function. See, I still do the same thing all the time. Hopefully I can erase it on this side. Okay, so all of those, try not to visit. I'm going to pause so that you don't have to watch me erase. Oops. I got to pause the video, not just pause me sharing. Hold on. All right, save you that pain of watching me do that. Okay, so there's the first 10. I'm just going to kind of go quickly through them. 11 times 11 is 121. I don't want it in red, but it already is. 12 times 12, 144. 13 times 13 is 169. 14 times 14, 196. 15 times 15, 225. 16 times 16 is, oh my gosh, where I just lost it for a second. 256, sorry, brain for a second. 289. 18 times 18 is 324. 19 times 19 is 361. And finally, we have 20 times 20, which is 400. So perfect squares. It's helpful to know for lots of different reasons. Put that on your quarantine list of things to do, right? Okay, so Beautiful, all those perfect squares. Well, let's talk about a little bit of an extension on that, and this is this one. I don't want to accidentally erase the wrong thing. Okay, well, what happens when it's a negative number? So, for example, like -1 squared. Well, again, it's a base. It's the base to the exponent here, right? So without using red, because who likes red pens? We don't want that. This is saying -1 times -1, which is, again, a positive 1. Here we have a -2 times a -2. A negative times a negative is always a positive, right? So even if it is a negative number squared, it's always going to have a positive result because any number times itself will be positive. So -3 times -3 is 9. -4 times -4. Why is that there? I don't know. Go away, Disney. Okay. I shouldn't say that word. I'm not copyright. I don't own Disney. 16, 5 times 5, or -5 times -5 is 25. -6 times -6 is 36. -7 times -7. -8 times -8. -9 times -9. And -10 times -10. Again, so yes, this list here is going to match this list here. So 1 squared is the same thing as -1 squared. 2 squared is the same thing as -2 squared, right? We do need these parentheses around it, right? -1, oops, sorry, talk backwards. I meant to draw parentheses. You guys miss all my miss marks, don't you? All right, so negative, we'll say, we'll do a -11. Squared is 121, right? -11 squared is different, right? The parentheses, think of it like a hug, right? So that parentheses, that's happening first. If we do our order of operations, P comes first before E, exponents, right? Parentheses. So what that's telling us is that we are squaring the -11. Versus this one is saying it's the opposite. It's the negative of 11 squared. This one, it's a negative of 121. So if there's a parentheses around it, you have to include the negative as your base. If there's no parentheses, that negative is not part of the base. It's outside. It's just telling me I want the opposite of 11 squared, okay? So that parentheses does make the difference. Okay, so just going through, I could have left that on there, but it gets so messy. So this is 121, 144, 169, 196, 225, 256. I don't know why 16 squared is really throwing me off today. 289, 324, 361, and 400. And as I said, multiplication grids help you get faster at this. I used to do it every day with my middle school students, so I became a champion of the 25s table. All right, so the next thing that we're going to look at, I'm going to make it smaller so we can see, is this, right? We're saying that x squared, if my question is x squared is 64, what can x be? So in my head, I ask myself this question. If x squared, sorry, I thought it would actually do it. If x squared, if x squared, if x squared equals 64, what can x be? What can x be? Okay, well, if I look up at my charts here, well, if I'm looking for 64, here's a 64, right? 8 squared is 64, but so is -8 squared. Both of those can be 64, right? So if the question is x squared is 64, x could be 8 and x can equal -8 because both of those equal 64. Okay, same thing here, 225. I go up to my list, I see a 225 here, and I see a 225 here. So what that means is that x could be 15, x could also be -15. All right, just one more of these. X squared equals -221. I see 221, but it's not a negative, right? So that must mean what? That means there's nothing, right? There is no answer. At this point, we're not dealing with negatives. I mean, we're not dealing with irrational numbers or anything like that. So at this point, Algebra 1, when we're looking at this, what squared is -121? No real solution. All right. They're not going to ask this on this test, but I just wanted to throw that out there for a thought. And that's that. Now, you're going to see something like these three, right? And you might have a moment of panic and don't. What I want you to think about is you already know this math, right? You already know a lot of stuff. Don't forget my moral of my always forever story. I'm going to make it nice and big for you to see. Do not forget the math. Oops, sometimes it jumps around. Do not forget the math you already know. Okay, that's the problem. A lot of kids get very intimidated. They see these problems and they're like, oh my gosh, what am I supposed to do with this? I don't know. What you do is don't forget the math you already know. All right, for a second, replace this. Say, I don't want to deal with x minus 5. I want to say that that's b. Make a variable. Okay, well, if b squared was 25, then b would have to be 5, right? Just 5? And -5, right? Because -5 squared is also 25, right? So b could be either one of these. Why did I name it b? Just so I didn't want to worry about that -5 yet, but I want to worry about that -5 now because b could equal 5. Well, that's going to be x minus 5. And if I just confused you a whole lot by putting that equal sign on the wrong side, well, A, there's no wrong side, but B, put it on the other side, equals 5, or x minus 5 has to equal -5. Okay? And then you solve the problem. So you add 5 on both sides, x could equal to 10, and I add 5 on both sides, x can equal to 0. Okay? Don't forget the math you already know. I'm going to turn away from red because some people get really intimidated by red, but I'm going to keep this somewhere here. Don't forget the math you already know. Okay, so I don't want to forget the math I already know. I know I want to get into this parentheses. I want to see how, I want to find x, right? But I have all this stuff happening to it, so I need to undo that stuff. The first thing I want to get rid of, because it's just, is this 3. Let's subtract 3 on both sides, right? X minus 3 squared now is going to equal to 100, right? That looks a little better. Because I know if I'm taking the square root of both sides, I know I haven't said square root in this video yet, but that's what I'm doing. Remember that just like addition and subtraction are inverse operations, multiplication and division, inverse operations, squaring and square rooting, or really exponents and roots, inverse operations here. So what you'll sometimes see, and as you saw in the other video, is they take the square root of both sides. Okay, I sometimes steer clear of it for a reason, but that's okay. So this is another way to think about it. So the square root of a square cancels out, x minus 3. The thing you have to remember is, what squared is 100? 10, positive 10, and negative 10. So set up the two problems. X minus 3 is 10, x minus 3 is negative 10. Add 3 on both sides. Oops, almost wrote down the number. X equals 13. My big, don't forget the math, you already know, is in the way. Plus 3, x equals -7. Okay, those are your two options for that. And then finally, I'll make this a little less annoying, but don't make it go away. And it's highlight it all. Highlight faster. I hope you guys just fast forward through my slowness in these videos, but I just wanted this to be smaller so that I don't ever forget it. Okay, don't forget the math, you already know. All right, so here what I see is I again see that square, so I know I want to take a square root. 4 is not so bad because it is a perfect root, but we're going to move on from that. Before I take my square root, I want to get rid of the extra stuff. Get rid of the extra stuff. I know that that's not really the math term, but that's how you can think of it. Okay, so what's extra right now is this 4. I want to get rid of it. Well, the 4 is next to this. What they're doing is multiplying. So unmultiply, divide. All right, so your x plus 1 squared is going to equal to 4. Take the square root of both sides. X plus 1 is going to equal to plus or minus 2, because the square root of 4 is 2. And I'll say that at the end. I won't say it yet. X plus 1 equals positive 2. X plus 1 equals negative 2. So x equals 1 and x equals negative 3. All right. So you will notice that squares and square roots, right? So if I could just go back for a little wrap up / new conclusion for you. Remember that these are inverse operations, right? So they undo each other. So if I got something like, for example, the square root of 144, that is going to go back to whatever the base was before. Okay, that might be obvious. That's fine. That's wonderful. But that's how you're going to do these problems. Please ask me if you have any questions. My moral of the story, what I'm going to tell you a million times is don't forget the math that you already know. Okay, math is logic. We're not teaching you this because you will be doing this in your job one day. We're teaching you this because you need to remember certain things. You need to remember that there are more than one option, right? We don't always do something the same way all the time. You need to know that sometimes two paths bring you to the same destination, okay? So that's my video for today, for this week. If you have more questions about square roots, let me know, and I'll be happy to make a video. All right, have a good one.